Thank you so much for joining this lesson. You go to the comment section and let me know whether you are hearing me well. Just use the comment section to let me know whether you are catching us up well. So our lesson is on equations and gradients of straight lines, as earlier on communicated. Make sure you subscribe and share this link with your friends. Subscribe and share the link with your friends as you continue following. So let me present the lesson. Yeah, the lesson is on equations and gradients of straight lines. The YouTube channel is Shifting Grades, and I'm delighted to host you today. Remember to invite a friend. Remember to invite a friend. You can on the comment section. Let me know whether you are getting us clear. Let me know whether you are getting us clearly. Yes, so let me start presenting my lesson now. Now that a good number has joined, we can get started. I will start by defining what a gradient is, and this is simply the ratio of the change in y to the change in the x-axis. In simpler terms, the gradient m of a given line is calculated by when we take the first y and the second y, then we subtract, divided by the change in x, that is the second x coordinate, and we subtract the first x coordinate. That will give us the gradient. But it's good I make it clear that the order in which we subtract these coordinates is not fixed. For example, I use the example provided here to make you understand what I'm trying to mean. A straight line passes through points 8, -2, and 4, -4. Find its gradient. Find its gradient. So for us to find the gradient, then we should be able to know that a gradient is usually given by change in x, change in y, sorry. So the first y and the second y subtracted in n order, divided by change in x. So the second x coordinate minus the first x coordinate. Let me now substitute this. I'll need to take the y coordinate here, which is -4. Then I subtract -2. You must have been very keen there. Minus -2. Then I divide by the x coordinate is 4 minus the other x coordinate, which is 8. And this is going to give us, when we take -4 and we subtract -2, it becomes a +2. So this is going to give us -4 + 2, which gives us a -2 out of -4. Because when we take 4 minus 8, we get -4. Then this will be, the negatives will cancel. Then we will find ourselves now having 2 out of 4, which is 1 out of 2. So the gradient is half. The same can be obtained if we take the equation, or if we take the gradient to be given by the first y coordinate is a -2 minus the next y coordinate, which is a -4. Then we divide this by change in x. So we take 8 minus 4. Therefore, this will be -2 minus -4, which becomes -2 plus 4, making it a +2 out of 8 minus 4, which is 4. And this again simplifies to half. Therefore, we are getting half regardless of the coordinate that we start with. So in either way, we are getting the gradient being correct. I want to mention something about the equations now of straight lines. And for us to get the equation of a straight line, then we just need to pick what we call the gradient of the line, and we express the gradient using one of the provided coordinates. Then we let another coordinate to be xy. So the equation of a line is given when the gradient is expressed using one of the provided coordinates. Then another coordinate is let to be y. Let me express the equation of the line above. We have a line whereby the gradient is already calculated as half. Then we have two coordinates, 8, -2, and 4, -4. Let me start by getting the equation of this line using the first coordinate. Therefore, I'll just use the gradient. The gradient is half. One coordinate is 8, -2. I should confirm that. Yeah, 8, -2. Then now we talk of another coordinate, which is let to be xy. Let me now express the gradient. When we say gradient, we mean the gradient whose value is known is given by change in y. That is y minus the y coordinate on the other side. So it will be y minus -2, making it a +2, divided by change in x, so x minus 8. At this point now, allow me cross multiply. And when I cross multiply, I will have 2 multiplying y plus 2. This is equal to 1 multiplying x minus 8. So I'll have 2y plus 4 equals to x minus 8. Then I will have now 2y equals to x minus 8 minus 4 becomes -12. And this means now the equation will be given by, when we divide through by y, we can have, we divide through by 2, sorry, to have y equals to half x minus 6. So this is the equation in the standard format, which we call y equals to mx plus c. It's also good we notice that when the equation has been expressed in this format, the value of the constant there gives us what we call the y-intercept. The y-intercept of a line is the point where the line cuts the vertical axis, or rather the y-axis. Then the value just before x, which is m, this one is what we call the gradient, or rather the slope. I want to give you a simple assignment of expressing the same equation using the gradient, which is half. Then the other coordinate, which is 4, -4. And we let another coordinate to be xy. Express the gradient using this now, the second option of coordinate, and a coordinate xy. Let me know whether you are getting the same equation. Continue following. Make sure you are subscribed to the channel. Don't forget to share with friends. Don't forget to share with friends. All right, it's good we mentioned something about parallel lines. And basically, Parallel lines are lines which do not meet. In physics, you say these are lines which meet at infinity. Such lines have the same gradient, or rather they have equal gradients. The gradient of a line is equal to the gradient of another line which is parallel to the provided line. If the gradient of a line L1 is m, then the gradient of another line L2 parallel to line 1 is also m. So that is something to be noted. Something to be noted. If a line has a particular gradient, then another line parallel to the first one should be having the same gradient. Let me look at a sample question which has been attached here. We are told that a line K is parallel to a line L whose gradient is -3 out of 2 and passes through the point 1, 0. Write down the equation of K. So there is a line K parallel to another line L whose gradient is -3 out of 2. So the only conclusion we're going to make here is that the gradient of K will be the same as the gradient of L, and that is -3 out of 2. That is the first conclusion to make. -3 out of 2 is equal to, because now we want to express the gradient using the provided coordinate 1, 0 and another coordinate xy. So now we need to take change in y over change in x. When we take y minus 0, then we divide by change in x. So x minus the x coordinate on the other coordinate is 1. Therefore, I'll be proceeding now to cross multiply, whereby I'll multiply 2 with y, or 2 by y. That will be 2y. After minusing 0, it just remains y. Then -3 should be multiplied by x minus 1. And this will be 2y being equal to -3x positive 3. So now we can have the gradient by having y equals to -3 out of 2 x plus 3 out of 2. So this is now the equation of line K, which is parallel to line L. Let's proceed and see something about perpendicular lines. We say basically perpendicular lines are lines which meet at right angles. They meet to make 90 degrees. The product of their gradients is usually 1. So when you multiply the gradient of a certain line with the gradient of another line, which is perpendicular to the first one, we are supposed to get -1. If the gradient of a line is m1, the gradient of m2, or the gradient m2 of another line perpendicular to the first should be such that when we take m1, we multiply by m2, we are supposed to get a -1. We're supposed to get a -1. You're supposed to get a -1. Yeah. So let us continue with perpendicular lines. Let us continue with perpendicular lines. We have just said that the product of the gradients of two lines which are perpendicular to one another is usually -1. We have a sample questions here, and I'm going to read the several questions, then we evaluate them. The first question is saying that a straight line L passes through the point 3, -2, and is perpendicular to another line whose equation is 2y minus 4x equals to 1. Find the equation of L in the form y equals to mx plus c, where m and c are constants. Where m and c are constants. Therefore, what we should know is that from the first line, which has been provided, such that the equation is 2y minus 4x equals to 1, we should know that the gradient cannot be obtained until the equation is in the format y equals to mx plus c. So now I'm supposed to first of all rearrange this equation. 2y equals to 4x plus 1. Then we can remain with y equals to 2x plus half. Now, when the equation is in this format, we can know that the first gradient here is 2, the coefficient of x. So with the gradient now, we can get the gradient of another line, gradient 2, such that when the two gradients are multiplied, they give us a -1. Therefore, that other gradient should be the reciprocal of the first one, but now with the reverse or with the opposite sign. Yeah, with the opposite sign. Therefore, a negative half. When we multiply -half by 2, we get -1. So those are gradients for two lines which are parallel to one or perpendicular to one another, that is perpendicular to one another. Now we have to express this gradient now, because we have the gradient and a coordinate. The provided coordinate is 3, -2. 3, -2. Then we have to let another coordinate now to be xy. With a coordinate xy, a provided coordinate, and the gradient of a line, then we can get the equation. We can get the equation. This is going to be expressed now. We express the gradient, -1 out of 2 equals 2. Change in y, so y minus -2. That becomes a +2. Divide by change in x, x minus 3. Then now we cross multiply such that we will have a 2 multiplying y plus 2. This is equal to -1 multiplying x minus 3. Then we're supposed to get 2y plus 4 equivalent to -x +3 when the bracket is open. We can remain with the 2y equals to -x. We have a +3 minus 4. It becomes a -1. So we can remain with y being equivalent to -half x minus half. So this is now the equation of the line in the said format. Allow me answer another question. Number 2, still on perpendicular lines, but a bit technical and different from what we've just handled. This line is talking about, or the question is talking about another line now. Find the equation of the perpendicular bisector of line AB, where A is 39 and B 75, giving my answer in the form AX plus BY plus C equals to 0. So let me now show you how to handle this question. A perpendicular bisector, first of all, we know that the line will be perpendicular to AB. But apart from that, something else we should note is that this line passes through the midpoint of AB. So if the coordinates of the midpoint of AB is let to be n, then we can evaluate the coordinates of the midpoint of AB. And the coordinate of n, the midpoint of AB, is going to be given by, we get midpoints by taking the first x plus the second x, then comma, the first y plus the second y, then we divide by 2. We need to take 3 plus 7, then we divide by 2. Midpoint are going to be 10 over 2, 5, 14 over 2, 7. So the midpoint of the line is 5, 7. Allow me proceed now to talk about the equation. Because we have a point where the perpendicular line passes, or the perpendicular bisector passes, it's good we get the gradient of AB. The gradient of AB, whereby we need the change in y. So I'll pick 5, I subtract 9. Then I divide by change in x, 7 minus 3. This is going to be negative 4 out of 4. And this simplifies to negative 1. If the first gradient is negative 1, then the second gradient, the gradient of the perpendicular now, should be 1. So that when the two gradients are multiplied, they will give us a negative 1. They will give us a negative. Therefore, now we can express negative 1 as the gradient. Change in y, we'll have y minus 7 and x minus 5. Then we cross multiply, we shall have okay, the format has changed according to the instructions. We are giving in the format ax plus by plus c equals to 0. Therefore, I will have y minus 7 equals to negative x positive 5. Therefore, we can start with x above plus y. Then minus 7 minus 5 should give us minus 12, equivalent to 0. So now this equation is perpendicular to AB, and the equation is. Thank you so much for following. Continue subscribing, continue inviting more friends, as we continue learning together. Yeah, this is good. They said you can type a public message. You can even tell us where you are watching from. Can see a few guys complaining that they cannot see clearly. We are working on that. Sorry for any inconveniences. I can see Ambassador Foundation, that is Mr. Alex Kipruto, together with a team from Loreto. That is great. Feel recognized, Mr. Alex and your girls. Double intercept, please, teacher. I will handle that. Thank you so much. Teach us more about 3-dimension. That is what I'm going to teach in the next lesson. Thank you so much. You can feel free actually to communicate the topic that you'd like us to handle next. I can see Mr. Tyson following. Thank you so much, my brother. Tyson Nalo following. Thank you so much. Thank you so much. Let us proceed now. Let us proceed. We can talk about, I know somebody has already requested about the double intercept form, and we are going to handle it. Proceed. The x-intercept and the y-intercept. Just to define what these points are, and these are the points where a line cuts the x-axis, y-axis respectively. What we should know mathematically is that at the x-intercept, the value of y is usually 0. That is the point let me try to sketch the information about the x-intercept and the y-intercept. Let's say, for example, we got a line here. This is our y-axis, x-axis. Then we have a straight line. Now, which is intersecting with the y-axis at some point. Let's say this is P. With the x-axis at some point, we can call this point, let's call it point Q. Yeah, let's call it point Q. Now, the coordinates of these places, we might not know them, but something we are sure about is that along the x-axis, we shall have a certain value of x, but the value of y is supposed to be 0. Something else we know about the vertical intercept, or rather the y-intercept, something we know is that the value of x is usually 0. That is something we are sure, but there is a certain value of y that we don't know. So that is the nature of the intercepts. Therefore, when we talk about at the x-intercept, the value of y is 0. Then that is what we mean. And also, at the y-intercept, the value of x is usually 0. But again, there is a better approach whereby we say that when the equation of a line is in the form y equals to mx plus c, c is the y-intercept of the line. And we are going to see that. We're just going to see that. Because naturally, in such a format, whereby we are saying when the line is in the form y equals to mx plus c, then we are saying this one is the y-intercept. Why do we say so? Why do we say that it is the y-intercept? This is because at the y-intercept, the value of x is 0. Therefore, when we substitute 0 where there is x, then the term there becomes 0, and the value of y will directly be equated to the constant c. So that is why we just conclude that instead of tiring yourself so much to substitute 0, it will simply give us the value of y-intercept to be equal to the value at c. Yeah, so that is something which has to be known. Allow me to talk about a question here. The nature of part C, together with another question here. I'm going to handle all these questions. But before then, allow me mention that to determine the coordinates of the point of intersection of two straight lines, solve the equations of respective lines simultaneously. Sometimes you'll be told to find the point of intersection for a given pair of lines. To handle that, you are just supposed to solve the two equations simultaneously. When we are handling graphs and coordinates, if you remember very well, you will discover that you talked about simultaneous solutions of equations using the graphical method. Simultaneous solutions of equations using the graphical methods. And whenever two equations or two graphs of straight lines have been plotted, their point of intersection, the coordinate of the point of intersection gave the simultaneous solution to the respective, which is the simultaneous solution. Hello? Niko live bana. Sorry for some inconsistencies here and there. Let me post my screen once again. Let me post my screen. Yes, sorry for the interference. Sorry for the interference. So we can now look at a question here. A straight line. Yeah, the question is here. I can access. Passes through points 8, -2, and 4, -4, and 4, -4. Write its equation in the form ax plus by plus c equals to 0, where a, b, and c are integers for 3 marks. All right, the first thing to determine, as we have just agreed, is the gradient. We are already given the coordinates. Therefore, for us to get the gradient, we need to take change in y, whereby we need a -4 minus -2. I think we have seen this equation. Divide by change in y, 4 minus 8. So this is going to be -4 plus 2. That becomes -2 out of -4. And this will simplify to positive half. So if the gradient is positive half, now we can express positive half using a coordinate xy and one of the provided coordinates. Let me use 4 -4 in this case. So y minus -4, making it a positive 4, divided by change in y, change in x, that is. So x minus 4. We cross multiply, we shall have x, x minus 4 equals to 2y positive 8. Now there is a format in which the equation should be. So we have to arrange the equation now in that format. This is going to give us x minus 2y. Then we have -4 minus 8, giving us -12 equals to 0. So this is now the equation in the said format. If the line cuts the x-axis at the point P, then determine the coordinates of P. So we have just mentioned, that at the x-intercept, the value of y is 0. Therefore, now we equate our equation. We take our equation, which is x minus 2y minus 12 equals to 0. And now where there is y, we substitute with 0. So x minus 0 minus 12 equals to 0. And this will mean that the value of x is 12. So if we are to get now the coordinates of P, then it will be 12, and the coordinate of y is usually 0 at the x-intercept. Part C, another line which is perpendicular to the line above passes through point P, the P which has been determined in part B up there, and cuts the y-axis at the point Q. Cut the y-axis at point Q. Let us first of all talk about this line perpendicular to the line above. If the first gradient is half, then we should talk about a second gradient now, which is -2. So that when the two gradients are multiplied, they give us a -1. That is for perpendicular lines, as we mentioned earlier. Therefore, now we can express our equation -2 equals to change in y, so y minus 0 out of change in x, so x minus 12. Yeah, because the line passes through P. Therefore, we can cross multiply and have y equals to -2x positive 24. Now, this is another line. It's already in the form y equals to mx plus c, and we want to determine the coordinates of Q. in which the Q is our y-intercept, the point where the line cuts the y-axis. Therefore, we said when the equation is in this format, we can simply extract the y-intercept as the constant at this point. Therefore, we're going to say that now our y-intercept is simply 24. So the coordinate there, Q, will be 0 because at the y-intercept, x is usually 0, then 24. So that is the coordinates of Q. We got another question here and more to come. Remember to continue subscribing and inviting more friends as we continue handling questions on equations and gradient of straight lines. Just invite as many friends as possible. Invite as many friends as possible. Yeah. Number 2, another question. Another question here. This question is talking about a line which passes through -2, 3 and -1, 6 and is perpendicular to L2 at -1, 6. Find the equation of L1. The equation of L1 will be found when we first of all find the gradient, such that change in y will take 6 minus 3 out of change in x, -1 minus -2. So this will give us 3 out of +1. And basically, the gradient will be 3. Now we can express our gradient so that we may get the equation. 3 equals to change in y, so y minus 3 out of change in x. Therefore, x minus positive minus -2 minus -2 minus -2, which becomes a positive. Therefore, y minus 3 equals to 3x +6. So now we can have y equals to 3x +9. So this is now the equation of line 1. That is the equation of line 1 in the form y equals to mx plus c. We can continue with part B. Find the equation of L1 or L2 now in the form ax plus by plus or minus c equals to 0, where a, b, and c are constants. The line is perpendicular to L1, which means the gradient of L2 is -1 out of 3. Remember, when two lines are perpendicular to one another, the product of their gradients should give us a -1. And this can quickly be found by simply obtaining the reciprocal, and we insert the opposite sign of the first gradient. If the first gradient in this case is a 3, then the second gradient for the line perpendicular to L1 should be the reciprocal of 3, that is a third. And because 3 was positive, now a third should bear a negative. So that is simply how we obtain the second gradient. I hope students will not have a challenge as we continue with that. I hope students will not have a challenge as we continue with that. Continue following. You can see the numbers are increasing. Share with your friends. Continue suggesting the topic you'd like us to handle next. Just feel free to communicate. Because now the line is passing through -1, 6, then we can again express the gradient. Change in y will be y minus 6 out of change in x, x minus -1, which becomes a +1. Then with this now, we can cross multiply, whereby 3y, sorry. Yeah, we'll have now 3y minus 18 equivalent to -x minus 1 when we multiply by -1. Then now, to have it in the format said up there, we will start with x, then we add 3y, And because we have negative 18 and we are adding 1, then we will remain with negative 17. This is, this is equal to 0. This is equal to 0. Therefore, that is the equation in the format which has been specified. We got another line, part C. Part C, we have another problem here. We are talking of another line, L3, parallel to L1, and passes through point 1, 2. Find the x and the y intercepts of L3. I will also take this opportunity to teach what we call the double intercept form. The double intercept form. Something which has been asked by a student here. The double intercept form. Because a student has asked, I'm going to answer the student at this point now. When two lines are parallel to one another, they have the same gradient. If the gradient of line 1, if the gradient of line 1 is 3, then the gradient of line 3 should be equal to the gradient of M1, and that is 3. The line passes through point 1, 2. Therefore, we can now express the gradient. We can express the gradient and say 3 equals to change in y minus 2, out of change in x minus 1. Therefore, now we can have y minus 2 equals to 3x minus 3. And with this now, allow me first of all have the equation in the original form, which is y equals to mx plus c. And now I will take you to the double intercept form so as to confirm what I will be arguing about the double intercept form. But first of all, let us have our equation as y equals to 3x minus 1. When equations are in this format, we said the y-axis or the y-intercept can be obtained directly from the equation. So we will say y-intercept equals to negative 1. Then at the x-intercept, the value of y is usually 0. Therefore, we will write the value of y as 0, because we have the equation there, equals to 3x minus 1. So x can be positive at this side and have 3x. That is 1, sorry. We can have 1 being positive. We can have 1 being positive. Then we remain with the 3x. And this will give us x as a third. So the x-intercept is a third. The y-intercept is negative 1. Now, when we talk about the double intercept form, we mean when the equation is in the form y equals to x out of A plus y out of B, or the equation can start with x out of A plus y out of B equals to 1. So when the equation is in this format, it is said to be in the double intercept form. And for your information, when the equation is in this format, we say the coefficient of x gives the x-intercept of the line. The coefficient of y, when we obtain the reciprocal, we usually get the y-intercept of the line. So it's good to underline that the coefficient or the reciprocal of the coefficient of x gives us the x-intercept. The reciprocal of the coefficient of y gives us the y-intercept. Let us work on the equation up there. We can have the equation now, starting with 1 equals to 3x minus y. This is now our double intercept form for the equation that we have. For us to get the y-intercept, we have to take the reciprocal of the coefficient of y. The coefficient of y is negative 1. Therefore, the reciprocal of negative 1 is just negative 1. So we were correct. Again, we can talk about the reciprocal of the coefficient of x. The coefficient of x is 3. Its reciprocal is a third. That gives us the x-intercept and will be correct. So that is how we handle it. Finally, there is a task here. You can be sometimes asked to determine a certain angle which is made by a line and the x-axis, or rather sometimes with the y-axis. And it's good to know that when we have a straight line, call it BC, then we have the angle it makes with the horizontal. You discover that there is a ratio which we call the tangent. That's a trigonometric ratio. The tangent of the angle is given by the opposite length, or number of units on the opposite length, divided by the number of units in the adjacent length. That means we need to take AC divided by AB. Again, the gradient of the angle at this point, the gradient of the angle at this point is usually given by the change in y, which means the number of units on AC, divided by change in x, which means the number of units on AB. And that means, again, we can get the gradient of a line by taking AC out of AB. This simply means if the tangent of an angle is also being equivalent to the gradient of the angle, then for us to obtain the angle made by a certain equation and the x-axis, we need to take the gradient and we obtain its tan inverse, because the value of the gradient is also the value of the tangent of the angle made by the x-axis and a certain straight line. Let's take a simple example provided here. The equation of a straight line is 2y minus 4x equals to 1. Find the angle between the line. The line should be the line and the y-axis, the x-axis, sorry, and the x-axis. So the angle will be found by, we first of all express the equation in the form y equals to mx plus c. This will help us to get the gradient. 2y equals to 4x plus 1. So y equals to 2x plus half when we divide through by 2. And this means the gradient is 2, that is the coefficient of x, and also the tan of the acute angle is also equal to 2, which means for us to get the angle now, we need to obtain the tan inverse of 2, and this will give us the angle made by the line and the x-axis. Tan inverse of 2. This will be 63.43. 63.43 degrees. Continue suggesting the lesson that you'd like us to handle next. Thank you so much for following. Remember to subscribe and to share this lesson with your friends. Invite more people to Shifting Grades. Thank you so much.